Welcome to Study Loop.
So in this problem, the only thing that will change here is the moment of inertia, but other than that, all the calculations will be same. So first of all, we should identify the total kinetic energy, which is kcm plus k rotational, where kcm is, let's say, if the object is just a uniform solid cylinder. So let's say this is the cylinder that we have, and if this cylinder is rolling without sleeping, that means the center of mass is moving linearly, right? And because of that, we have a velocity associated with it, and that's why we have a kinetic energy which is associated with the center of mass. And then we have a rotational kinetic energy since the cylinder is rolling without slipping. So, and also for an object that is rolling without slipping, we set a definition that the velocity of the center of mass is equal to r times omega. So this is just when we have a condition of rolling without slipping. So now if we want to write the fraction of total kinetic energy that is rotational, so that means the fraction, let's say, let's write that as fraction, will be equal to the rotational part of the total kinetic energy, which is 1/2 the moment of inertia when the axis is at the center. Yeah, that's the axis. Sorry for my poor drawing. Then we have omega squared, and we divide that by the total kinetic energy, which is half of m VCm squared. Since we said that this is just a linear motion, so we have the linear kinetic energy plus the rotational part, which is half of ICM omega squared. Right, so we'll be using this equation only for different parts, and as we mentioned, that only thing will change is the moment of inertia. So let's see, for the uniform solid cylinder, we know that I cm, or the moment of inertia of the center of the cylinder, is half of mr squared. And if we use this, we'll see that the ratio or the fraction will be 1/3. Similarly, for the uniform sphere will have ICM as 2/5 mr squared. So the ratio will be 2/7. For the thin-walled hollow sphere, ICM is 2/3 mr squared, and that gives us a ratio of 2/5. And finally, for the hollow cylinder with outer radius r and inner radius r/2, our ICM is 5/8 mr squared. So the ratio becomes 5/13. Thank you.